Cosmic Frog for Excel applications provide alternative interfaces for specific use cases as companion applications to the full Cosmic Frog supply chain design product. We'll take a look at a Cosmic Frog Excel application for Intelligent Greenfield. And this application is specifically focused on understanding the optimal number of facilities that are required for a given demand and supply profile. The application will allow the user to specify the demand quantities and optionally the supply quantities, provide information on existing facilities that must be part of the solution, as well as specific candidate facilities that must be considered. We can also define fixed cost and throughput capacities for the facilities, as well as variable costs associated with the supply and demand. Running the Intelligent Greenfield engine will also automatically generate additional candidate facilities that can be considered, and the Excel application will return both the optimum facilities as well as the demand and the supply allocation within that supply chain. In this training video, we're going to learn how to build apps using Excel against the Optilogic platform. The training is broken into multiple chapters, so you can work through this top to bottom, or you can go into individual chapters to review the content. We'll start with an overview of the best practices and the best approach to building an Excel app against the Optilogic platform. We'll then review the Optilogic VBA module, and this provides lots of standard functions for working against the platform. We'll cover app keys which are used for authentication and how to persist these securely. We'll also look at exporting data locally from Excel. We'll also look at building a job being the logic that we actually want to execute for the app on the Optilogic platform. We'll then see how data downloaded from the Optilogic platform can be updated within the Excel app using an array. And then finally, we'll bring all of this together and show you how it works in terms of a Greenfield app that allows users to run the Greenfield model and explore different scenarios from Excel. In this chapter, we're going to cover the best practice approach to building an Excel app. So on the left-hand side of the screen, this represents everything that will be happening outside the Optilogic platform. So this would be the Excel app running on your local machine. And on the right-hand side of the screen, this is going to represent everything that's running and happening on the Optilogic platform. So the first thing we'll do is we'll export the data from the Excel app into an appropriate file format. Usually this would be CSV file, comma separated value, or a text file, but it could be any appropriate file format that's really supported by Python. The next thing we'll do is we'll upload the data to the Optilogic platform, and we'll see later on in other chapters how we can use a standard function that's been provided to do this. And now we have the data in the Optilogic cloud. The next thing we'll do is we'll run the job programmatically from Excel using the standard function library, and what that will do is that will run the logic on the Optilogic platform. So this could really be anything that we build in Python. So at the end of running this job, we'll be putting data back down into an appropriate file format. So for example, this job may have updated and run a Cosmic Frog model, and we've taken data out of the output tables from the Cosmic Frog model and made that available on the platform. The next thing we can then do is download that from the platform so we have it locally. And again, we'll explore how we can use a standard function to be able to download the data so it's back alongside our Excel app. And then finally, we can take that data that's been downloaded from the platform and we can process it back into the Excel app, updating sheets and results for the user. One thing to bear in mind is when we bring the data back, if we bring it back from the platform, we may need to convert the format into Windows before we handle the data. And again, there's a standard function to be able to do that, and we'll explore that in subsequent chapters. So to summarize, we'll be exporting the data to an appropriate format, uploading that data to the Optilogic platform, and then being able to call from the Excel app to execute the job, to run the logic, to run the model, to be able to export the data and then download that locally, convert it where necessary, and then be able to update the Excel app. In this chapter, we're going to learn how to use the Optilogic VBA module to work against the Optilogic platform. The Optilogic.bas file is a VBA module, and that can be very easily imported into any macro-enabled workbook. So once we've imported the Optilogic.bas file, we'll have access to a range of useful functions. In this chapter, we'll concentrate on the functions that work against the Optilogic platform. And we'll learn how to upload data locally into the Optilogic platform, where we can specify where that data exists locally and what the file is called, and where we want to land it in the platform and what we want that file to be called when it lands. We'll look at doing that the other way round, downloading a data file from the Optilogic platform, specifying where that file is and where we want to land it locally. And then we'll also look at running jobs on Optilogic. So this is going to be the logic that might update the model, run a scenario, and then be able to export results. And we'll also learn how to monitor that job. So locally in the Excel app, we can see how that job is progressing on the Optilogic platform. To work against the Optilogic platform, we'll also need to provide app keys for authentication. So in Chapter 3, we'll learn how to use the functions for app key management and also getting the workbook file path. And in Chapter 4, we'll learn more about exporting CSV data and how we can use standard functions to do that. So now let's take a look at the best practices template that you would have downloaded from the resource library. We can also see that we have the optilogic.bas file. This is the VBA module that can be imported to any Excel enabled workbooks. You can use the library. So if we open up the best practice template, because it contains macros, the first thing you'll need to do is to enable the content. And the first sheet just gives us an overview of the best practice that we've been through in the previous chapter. There's also lots of useful getting started information, so enabling the workbook, how you're able to actually access the VBA code. Often you might not have this developer feature enabled, and you can actually go and add it into the ribbon bar. And then there's some additional steps that show how we can use the developer controls to add buttons, assign macros to buttons, and also access the pre-built macros that we've got as examples in this best practice spreadsheet. So let's jump in and start looking at the functions. To get to the code behind each of these examples, we can either go to the developer tab and simply open Visual Basic, and then here we can see we've got the examples and we've also already got the Optilogic module imported. If this was a new Excel workbook and we wanted to import it, we can very simply go and select Import File and select that Optilogic BAS file. But we can also go behind the button, click Assign Macro, select the macro that we want, and we can edit it. And here we can see that it's opened up the Upload Data function. Let's now configure the Upload function. So the first thing we can do is just remove these lines that give a message to the user in the best practice spreadsheet. And then what we need to do is we need to bring in the app key from a local file. This will be addressed in the app key chapter of the training, but it's really important never to put the app key directly inside the code, otherwise you might accidentally share it with other users. So now let's set the parameters that we need for the function. So the first one is the local path to the file and the file name. So I have my data file here locally, it's called mydata.csv, and if we open that up, then we can see it's a very basic few rows of data for a couple of columns. But this is the data that we want to upload to the Optilogic platform. So what we can do is we can take the path to that local data and we can put that instead of the default, and then we can give the local file name mydata.csv. Now we need to define where it's going to land in the platform file path, and also the name we want it to be called. So the easiest way of doing that is to navigate across to the platform, and I want it to upload to this folder called app data. You can simply right hand mouse click and copy the folder path, and then we can return back to our VBA and we can put that path in there. And we could land it as a different file name, but I'm going to land it in that folder within the platform with the same file name, mydata.csv. And then finally, we don't need this line at all. We can either comment it out or actually get rid of it altogether, because the app key that's going to be passed through to the function is being read in from that local file. So now we're ready to test out what we've built. So we can either run that directly from here, or we can go back to the Excel spreadsheet and we can click the upload file to Optilogic button, and what that will do is it will take that file and then we'll see that file land up here in the Optilogic platform. And here's my data.csv. If we click on it, it will actually open up in Lightning Editor We can see that that data is now landing in the platform, and we'll just make a couple of small changes to that data set for the purposes of showing those changes when we then download it. So now let's quickly configure the download data function. Again, we can remove these two lines. We will bring in the same piece of code that loads the app key from the file, and we can also remove this line because the app key is defined. And we're doing this in reverse now, so we're defining where we want it to come from on the platform, the file that we want to pick up, the path that we want it to locally, we'll replace the default, and then the local file name we're going to change up slightly. So we'll actually say that it's my results. And now we can test that out by simply running it, and that will get the file, download it from the Optilogic platform, and we'll now see in that defined file path we have my results. And if we open that up, we can see that that's the downloaded file with those changes to the data. Now let's look at running a job on the platform. So here I've created a very basic job. It's called myjob.py. It's actually in the same folder as the data we've been uploading and downloading, and it's as simple as it gets. It simply prints out hello world. So let's configure the example. Again, we can get rid of these two lines at the top, and we also need to get the app key from the local file, which means we no longer need to define it there. So what we're saying is that the job path on the platform, this is going to be an app data. So we can simply get that as we did before and put that in place. And the job we want to run is myjob.py. And this function here will run the job on the Optilogic platform using the path, the job name we've specified in the app key, and it will return a job key which we can then pass into the function that monitors the job on the Optilogic platform. Now, other parameters we can pass into monitor job on Optilogic are the worksheet where we want information to be updated, and we've set that to the module functions worksheet here. We can also define the interval, so this is how regularly we want to check on the progress of the job. And then we also have the user message that we want returned, and we can define where this was returned to. So we can see here that we're returning the message to module function sheet cell M3, the status to cell M4, and the time at the last interval of check to cell M5. So now we've configured that function, we can simply click the button. What that will do is start the job, and we can see that starting on the Optilogic platform in the cloud. We can see the statuses come back. So while the job's being monitored, we can see this is the job key and that it's still running. The status is running, and also the amount of time from the last check. And now that's completed successfully, we can see that the status has turned to done. And over on the Optilogic platform, we can see that the status has also returned to done. And so to summarize, we've configured examples in the best practice spreadsheet for each of those capabilities: uploading data to the Optilogic platform and downloading the data file, and also running and monitoring a job. And we can use these standard functions to follow the best practice, where we will be taking data that's been exported from the Excel app locally, uploading it, executing that job from the Excel code, and then being able to download data. And we'll look later in other chapters at processing that back into the app itself. In this chapter, we'll understand file paths, how to be able to dynamically get the file path, and also how to deal with files that are in cloud synchronized drives. And we'll also cover app keys and best practices around persisting those. App keys are used to authenticate the user from the Excel app. App users will be able to get the app key from their Optilogic account details. Your Excel app must allow the user to enter this app key that they get from the Optilogic platform. But this app key must not be saved directly within the Excel workbook. Saving the app key directly within the workbook means that these user credentials could accidentally be shared with other users. So now we're going to take a look at the best practice where we can take the app key from the Excel spreadsheet at runtime and store it externally in the app.key file. So now let's open the file app key best practice example. And because this is a macro enabled spreadsheet, we'll need to enable the content. In cell B2, the user can enter the app key that they get from the Optilogic platform. If the Excel workbook is in a folder that's synchronized with a cloud drive, the user may also have to enter the local path to the Excel workbook in cell B3. The path to the Excel workbook is important because this is where we're going to persist the app.key file. So now let's take a look at the VBA code behind this button. And the first thing we need to do is to get the valid file path, because this is where we're going to persist the app.key file. And we're going to use the getWorkbookFilePath function, which is a standard function in the Optilogic VBA library. Now it's possible that the Excel app workbook is actually sitting in a folder that's synchronized with a cloud drive, for example OneDrive, at which point we'll need the user to tell us the local path. So we're going to pass this information into the function. So we're going to pass in the sheet name, which will be the admin sheet, the cell, which is B3, in which we expect the path to be entered, and also the message we want returned to the user should the path either be invalid or the workbook exist in a cloud synchronized drive. So now let's run this code. We can either run it directly from within the VBA debugger, or we can click the button to run it. And we can see that when we run the code, a valid file path hasn't been found for the workbook. So this must mean that it is in a OneDrive that's been synchronized. So we're going to need the user to give us the file path, and we're directing them to step 4 on the admin sheet that gives them instructions on how to do this. So let's go and do that quickly by simply taking the file path and pasting that into the spreadsheet. Now if we run that code again, we can see that we get a different message, and it's validated the path. We know what the path is going to be, but now we're looking to validate the app key. And we can see that we're using the manage app key function. This again is a standard function in the Optilogic VBA library. We're passing in again the sheet name, admin, where the app key is going to be. The app key is actually in B2, and then we can also put the user message that we want displayed if the app key is invalid. And this function is going to validate the app key. If it's valid, it's going to persist it and take it out of the spreadsheet, so it's no longer persisted in the spreadsheet. And this function will also test to see if an app.key file already exists, and if it does, it will read in the already persisted app key, and that will be the case if the user's already run the Excel app. So I've just added a little line here so we know that the app key is valid if it's validated. So we've already run it with an invalid app key. We'll just do that one more time. We can see there that the user is clearly told that the app key is invalid. So what the user can do is go and get their app key from the Optilogic platform, and they're able to put that into the Excel spreadsheet. So now when we run the app, we can see that the app key is actually valid. The manage app key function has both validated the app key, it's also persisted it to an app.key file that we can see here in the folder alongside the Excel app. And then it's also replaced the app key inside the Excel spreadsheet. So this can no longer be accidentally shared if we share the Excel spreadsheet with somebody else. And now each time we run the app, we can see that it's always returning a valid app key, even though it's no longer in the spreadsheet, because that file exists and it's always returning the app key from that local file. And so to summarize, we've seen how we can allow the user to enter the app key from the Optilogic platform into the Excel app. But it's also very important that we don't save that within the Excel workbook in case we accidentally share those credentials. And we've seen the best practice for being able to test the file path and then being able to save that app key locally in a file called app.key alongside the Excel app workbook. In this chapter, we're going to look at exporting data locally from the Excel app. So we're going to explore exporting data from a defined set of columns, but where the rows can be dynamic, and we will often see users adding additional rows of data within the app. We will also cover how we can export data from an unstructured format, so for example settings that might be defined for the app. So let's go and open our local data export example Excel file. And because this is macro enabled, we'll have to enable content. In this example, the user is providing a list of facilities with information around their status, lat long, costs and throughput capacities. And we're expecting the user to edit existing rows, but also add additional rows within this app. So now let's take a look at the code that's behind this button for exporting facilities data. So we'll start by exploring this function that exports data to CSV. We can define the file path where we want it to be written out to locally, and also the file name, the sheet where the data will be exported from, so in this case it will be facilities, the first row that we want to export from, and also the column range. So in this example it will be column A to F. And then what we'll do is we'll set the last row dynamically by effectively going N down, and this is going to get the last row in the data set dynamically, and then we can use that to set our range, which will be the fixed column range and then the number of rows dynamically. And then finally we'll create a workbook, copy that range, and then export that data out into the CSV format within the path to the file name that's been defined. Now let's take a look at calling that function in the code above, and we can see here that we're calling the export CSV file function. We are passing in the file path, which at the moment is fixed, but if you review the app key best practices chapter, that will cover defining file paths. We're defining the file that we want it to go to, which is facilities.csv, the sheet that we want it to come from, which is facilities. We're defining the column that we want to dynamically do the N down in and calculate the number of rows. And then we're also defining the column range, which is here A1 to F, and the number of rows will be dynamically calculated. And so now let's test that out by clicking the Export Facilities Data button. And what we can see is that will run successfully. And once it's run, it will have exported that CSV file. And if we open that up, then we can see that the data has been exported. And then when the user adds additional rows of data to the app, we can see we have 2 new rows of data here. If we run that again, we can see that it will replace the facilities CSV file. And if we open it up, it's dynamically selecting the rows, and we can see that those additional rows are in the exported data. Now let's take a look at an example where the data isn't in a structured column-based format. So these are settings for the Greenfield app, where users can select different values and input different numbers. So we've defined the file path where we want the data to be written out to, and we're also checking to see if a settings.csv file already exists, and if so, we want to delete it. We are then defining a variable for every single one of the parameters that is going to go into the Greenfield settings table in the Cosmic Frog and Nora database. And then we're referencing the data directly in the spreadsheet to be able to set these parameters. So here we're getting the value from C5 in the settings sheet, and we're testing to see whether it's set to optimize. If it is, then we don't have to pass any data through to this parameter, but if it's not set to optimize and the user's defined a number of facilities, then we're setting this parameter to the value that's been entered by the user. Another example is customer fulfillment cost, where we're setting it to the value of C6 that's been entered into the settings worksheet, and we're also trimming out any commas from that data that's been entered. We're also setting the resource size that's been selected by the user in the settings, and also the scenario name that's been entered. And again, we're taking those directly from the cell and the sheet into the variable that's going to be passed through as a parameter to Greenfield. And then finally, we're writing that out to a file called settings.csv. The first line is going to be each of the parameters, so the parameters for the Greenfield engine, and then we've also got the resource size and the scenario name. And then the second line is going to write out the variables that have been set to the parameter value defined by the user in the Excel app. So now let's test this out by clicking the Export Settings Data button. And we can see that if we go into Explorer, we have the settings.csv file that's been exported. And in here we have all of the Greenfield parameters set to the values defined in the app. And then we also have the resource size and scenario name. So all this data can be passed up to the Optilogic platform. And so to summarize this chapter, we've seen how we can export a more structured data set where there's a defined number of columns, but the rows will be dynamic as the app user adds additional rows. And then we've also seen how we can take more unstructured data, so for example settings that are defined in specific cells, and write those out to CSV files or any appropriate file format. In this chapter we'll cover building the job on the Optilogic platform. A job is a Python script that runs on the Optilogic platform, and in the context of an Excel app it's the logic that we want to execute. So this could be anything from transforming data to integrating against other things that exist in the cloud, running a custom engine, or often updating a Cosmic Frog model, running a scenario using any of our technologies, and then being able to take results back from running that scenario. A job can be built directly in our platform using Atlas, or you can use an external IDE, for example PyCharm or Visual Studio. And Cosmic Frog actually has a dedicated Python library that allows you to very easily build scripts that work against our supply chain data model, Anora. So I'm going to take a moment to call out this really great resource in the resource library, Scripting with Cosmic Frog, and you should definitely go and have a look at this. It covers building jobs in Atlas, building jobs in IDEs, and also using the Cosmic Frog library to update tables and scenarios. So let's take a look at jobs in the Optilogic platform. We can see here that we're in Atlas, which is our Python development studio, and this is the most basic job that we used in chapter 2 when we're understanding how to run a job from an Excel app. So let's walk through the job that works against the Greenfield Excel app. So this job, the first thing it does is it looks for a model called Greenfield app. And it may be that that model isn't there yet. It may be that the user hasn't run the app. So what it will do is it will try to create that model. If it doesn't exist, it will create it and connect to it. If it does exist, it will just connect to it and then clear out some of the existing tables because we're going to update it with new data. So you'll notice how easy this is to be able to script. This is using the Optilogic and the Cosmic Frog Python libraries. So with just one line we can create that model. With just one line we can connect to a model and we can define the name. And then we have a range of functions that allow us to easily clear tables, write data to tables, upsert data, run queries. And as I say, definitely go and work through the scripting with Cosmic Frog training that we have up here in the resource library, and it will give you a huge amount of detail on all those functions that are available. The next thing we'll do is define the scenario that we want to run within the model. Now this is going to be set to the baseline because effectively we're always rerunning the baseline in this app. We could of course extend this script to programmatically create new scenarios, but here we're always running the baseline. And we can also define the engine. We can see here that the engine is Triad, and this will run our intelligent Greenfield optimization engine. We're then able to import the data that's been uploaded. So this is the customer data that's going to go into the model. We're doing a small amount of transformation, and then again we're using the write table function from the Cosmic Frog Python library to very quickly upload that data directly into the customer's table. We're also importing the customer demand table, the facilities table, the suppliers table, and also the Greenfield settings table. And again we can see here that we're uploading that directly to the model into the Greenfield settings table. And this is actually consuming the file that we learned how to export from Excel locally in chapter 4 of this training. And now the model's been updated, we can run the scenario, and this piece of code here goes and runs the scenario on the Optilogic platform, and it monitors it until it's completed. And once that scenario has been run, then we can use the Cosmic Frog Python library to very easily read a table, and we're bringing back the results, the Greenfield results for facility summary and also flow summary. And then what we're doing is we're writing those out to a CSV file, so they'll land as results files here inside the Optilogic platform. And then of course we can use the VBA library that we learnt about in chapter 2 to be able to download this data back to the Excel app. Now it's important to make sure that the job ends up in the same folder as all the other data that's been uploaded from the Excel app. So to do this we can download the job and we can put that file in the same folder as the Excel app. And what we'll also do is just rename that file so that we obscure the file extension. So let's open up this example and we can take a look at the code behind the button. We've defined the local path from where we want to upload the data and referenced chapter 4 to learn how to define that dynamically. But what we also want to do is define where we want to put it in the platform. So we can go across to Lightning Editor, and in Explorer we can quickly get that path to the folder on the platform. To upload data to the platform, we'll need to be authenticated. So we'll either take the app key from the user input or load it from the file if the user's already run this app. And you can reference chapter 3 for all the detail on app keys. And then finally, we just need to call the upload file to Optilogic function as part of the standard VBA library. And we're going to give it the file path. We want to upload the file greenfield.job. We've specified where we want to put it in the platform. And when we land it in the platform, we're going to rename it differently and call it greenfield_job.py. And then that will be the job that the Excel app runs. For more information on this and all the other standard functions, you can reference chapter 2 of this training. So let's just test that out. What we can do is go to the Optilogic platform and get my app key, and I'll put that here in the Excel app. And then if we click the Run Example button, that will run. And if we jump over to the Optilogic platform, then we can see that that job has been uploaded and is ready to go in the right place for that Excel app. And so to summarize this chapter, we've seen how we're able to build a job, a Python script that runs on the Optilogic platform. And in this example, it's following that pattern of importing data to a Cosmic Frog model, being able to run scenarios and then export results, making them available as files that can be downloaded back to the Excel app. And of course, you can build a job on the Optilogic platform to do pretty much anything that's supported in Python. So definitely go and take a look at the Scripting with Cosmic Frog template and training video, and it will give you a much broader view on what can be built and achieved in a job on the Optilogic platform. In this chapter, we'll explore updating data in Excel using an array. Often, when building an Excel app, we need to be able to take data that's been downloaded from the platform and then update a specific range within a specific sheet. And this particular example is from the geocoding app. So what we've done is we've uploaded data to the Optilogic platform, we've run a job which has geocoded that data, and then from the platform we've downloaded the data in text format, and we want to be able to look up the lat longs back into the Excel app for the relevant customer. So let's take a look at the example. Geocoded data.txt is the data that's been downloaded from the platform. And if we open up the example, we can see that this is the data that we want to look up into. We want to bring in the lat long from that text file. So let's take a look at the code that's behind that button. So we've hard-coded the file path. We can reference chapter 3 to understand how that works in an app dynamically. And then we've also defined the file that we want to read in, geodata.txt, but this file has come back from the platform, so this will be in a Unix text format, and we need to convert that to a Windows format before we can read it into the Excel app. So to do that, we're going to use this function that's a standard function in the Optilogic VBA library, and here we're passing in the file that we want to convert with its path, and that's going to be geocoded data.txt. And then that will create a new file called geocoded data win.txt, and that's the file that we're going to read to update the sheet in the Excel app. So once that file's been converted, we'll count the rows in the file and use that information to dimension the array. So this array is going to have 3 columns: the customer name, the latitude and the longitude. The indexes in the array all start at 0, so we'd have columns 0, 1 and 2, hence 3 columns in the array. And it's going to have the number of rows that exist in the text file. The next section loads the text file into an array. It opens the file and it loops through the text file, reading each row at a time, and then each row is broken out into the 3 columns and loaded into the array. And then finally it will loop through each of the rows in the customer sheet, and where the customer name in the array matches the customer name in the sheet, the relevant cells within the customer sheet will be updated with the lat long information that's in the array. So now let's test this out. When we click the button, it's going to be taking this data in geocoded data.txt. This is data that would have come back from the platform after the job had run, and it's going to look that data up using the customer name, matching it against the data that comes in from the file. So if we click, we can see that that's pretty much immediately updated the latitude and longitude in the spreadsheet. And we can also see that we've got an additional file here This is the file that we actually read, which was the converted data to Windows format. So to summarize what we've learned in this chapter, often we need to take data that's come back from a job that's run on the platform, and we want to update a specific area of the Excel app within a sheet. So to do that, we've converted this data into Windows format, we've read it into an array, then we've effectively done a lookup. We've looped through all of the rows of data, matching the customer name to the data that we loaded into the array, and where it matches, we've updated the cells for latitude and longitude. In this final chapter, we're going to see how everything we've learned comes together and delivers a Greenfield app in Excel. So firstly, let's take a look at running the app as a user. So let's open up the Greenfield app. And because it's a macro-enabled spreadsheet, you'll need to enable the content. We will need to go and get our app key from the Optilogic platform. So we can go to our account, app key management, and we can paste that key straight into the app. And then because this is in a synchronized cloud drive, we'll need to go and get the path that the app is sitting in, and we'll need to add that in to the local path. And then as the app user, we'll put in demand data with a lat long for each of our customer points. We can optionally add supplier data with a quantity that's available to be delivered into the supply chain. And we can also add facility data. So here we've got an existing facility in Atlanta that must be opened. We can also add candidate facilities and specific facilities that we want to be considered as part of the solution. And then we're also able to define settings for the Greenfield, whether we want to optimize and have the optimal number of candidates returned, or whether we want to specify the number of facilities we want in the solution. Then we can put in unit costs for fulfillment and procurement. We can generate many candidates to be considered, or only use the candidates suggested in the facilities input sheet. And then we can also put fixed costs and capacities and minimum throughputs. We can also decide what size of container we want to run it on. So even though we're running it from an Excel app, we still have all the scalability of the Optilogic platform. And we can also give it a scenario name. So now we can run the Greenfield app from Excel. And when we run it, it will export all of the data. We'll upload that data to the Optilogic platform, and then it will run the job, which is going to update the model and then run the scenario. We can also see that all the data we've uploaded, including the job that's in the right space, the customer, facility, suppliers and settings data, has all landed in the platform. And now we can see that the job has started to run the baseline scenario within the Greenfield app model on the Optilogic platform. And now we can see that everything's finished running on the Optilogic platform, and I'll be notified in the app that everything's completed successfully, and I can now go and review my results. And if I go to the folder in which the Excel app has been run, I can see that I've got my results for both the facility summary table and the flow summary table. And if I open that up, then we can start to dig in and see in this case how each demand point was allocated to a distribution center that was opened as part of the center of gravity. And then of course you could take the app forward from here. You could consume this data, import it, update charts, graphs, etc. So now let's summarize how we built the Greenfield app using the best practice. So the first thing we do is we export the customers, suppliers and facilities data from the respective sheets, and then we also export the settings to CSV files. We then upload all of the CSV files and also the app key into the Optilogic platform. And now we can run the Greenfield job.py file. So this runs the job on the Optilogic platform, and that's going to import all the data from the different CSV files. It's going to either create or update an existing model, Greenfield app.frog, and then it's going to run the baseline for Triad, the intelligent Greenfield engine, and then it's going to export both the facilities and the flow summary data back out to CSV file in the Optilogic workspace. We'll then be able to download the facility and the flow result information back alongside the Excel app, and then we can notify the user that the results are downloaded in the CSV and ready for review. So to tie this back into the training content, understanding how to export both structured and unstructured data is all covered in Chapter 4. Uploading data, running jobs and downloading data from the Optilogic platform is all covered in Chapter 2, and this takes us into the standard Optilogic VBA library, persisting the user app key and also understanding how to work with file paths and where files may be in cloud drives. That's all covered in Chapter 3. And learning how to build jobs on the Optilogic platform that are called by the Excel apps, that's all covered in Chapter 5. So now let's take a look at the code and how we built this Greenfield app. So firstly, we're doing some checks that are specific to this application. So for example, we're checking here that the input on the settings sheet for the number of facilities is valid. We are then getting the file path to where the workbook is. We're using the get workbook file path function, the standard function from the Optilogic VBA library, to do that. We then need to ensure the user's provided a valid app key, and we're going to use the manage app key function from the Optilogic VBA library. And this is either going to get the user input and persist it in the app.key file, or if the user's already run the app, it's going to get the valid app key that will have already been persisted externally to the spreadsheet. You can reference Chapter 3 for much more detail on both these functions from the standard library. We then move on to writing the data out into the local CSV files. So we can see here that we're dealing with unstructured data, and we're exporting all the Greenfield settings that have been defined in the settings sheet, and we're getting the values directly from the cell references within that settings sheet and putting them into variables, and then we're writing out all of those variables to the settings.csv file, which will be passed up to the platform. And then we're using the function to export CSV files, and we're doing this to export the structured data that's in the customers sheet, the facilities sheet and the suppliers sheet. And all the detail on exporting both unstructured and structured data is covered in Chapter 4 of this training. And now we can upload all the data to the Optilogic platform, having exported the data locally to CSV and also got the app key for authentication. And we can use the upload file to Optilogic function, which is part of the Optilogic VBA library. And then we can see we're uploading the app key file, we're uploading the customers, the facilities and the suppliers data, as well as the settings CSV file where the user has defined the settings for the Greenfield model. And then we're also uploading the job, and this is important because we want to make sure that job lands in the right place and we know where the app is able to run it. So you can reference Chapter 2 to get much more information on using these standard functions and uploading data, and also Chapter 5 to understand how jobs should be landed in the platform to work with an app. Next, we're going to run that job on the platform, and here we can see we're using the run job on Optilogic function, another standard Optilogic VBA function, and here we're running the Greenfield job.py file, and then we'll also use the monitor job on Optilogic function to be able to monitor the progress of that job. And you can reference Chapter 2 of the training for much more information on how to use both of these functions, which are part of the Optilogic VBA library. So now let's go across to the Optilogic platform and see what's going to happen when we execute this job from the Excel app. It's going to look for a model called Greenfield app that either exists and will be cleared out, or if it doesn't exist, it will be created. After that, we'll be running the baseline scenario, and we're also defining the engine that we want to run. So the engine will be Triad, our intelligent Greenfield. We'll then import each of the data sets. So here we're importing the customers.csv that's been uploaded. There'll be a small amount of data transformation, and then we're using the Cosmic Frog Python library to write that data directly into the customers table. We're doing the same now for customer demand, for facilities and for suppliers, and then we're also reading in the Greenfield settings from settings.csv, and they're being written directly to the Greenfield settings table in the model. After that, we're able to run the model, and this is going to run the baseline. And then once that model has completed, we'll be able to export the results from the results table, the output tables, and then download them as CSV files. And these are the CSV files that will be downloaded by the Excel app. And once that job is finished on the Optilogic platform, we'll be able to download the data that's been exported from the job using the download file from Optilogic function. Again, another standard VBA library function. And we can see here that we're downloading both the facility summary and the flow summary, which are results from the Greenfield model. And then finally we notify the user that everything is completed successfully and letting them know where to go and look at the results.